All right, before we get into the meat of the regulations on Part 107 and all that, I want to acclimate everybody to the weather coding system. It's really interesting that they still require this on the 107 test because nowadays you can literally request the information when you're a pilot. You can request it in plain English, so you don't really have to know the coding. But for some reason, the FAA still includes it as a part of the test. So we're going to need to learn it if you want to get every question on this test correct, or at least as many questions as possible correct. We're going to need to learn this portion. Now there's so many codes and there's so much going on that you will probably need to study additional aids for weather coding. And so I'm including with this video link, you'll notice there was a link for a like a pamphlet or a manual that's put out by Bendix King, which is Bendix is an aviation company, and King Schools is a school for aviation. So the two of them got together and created this pamphlet. So at any rate, I think it's important that you not only watch this video and get the basic ideas, but if you want to know what each one of the different codes means, that video would take hours to get through, whereas you can read through the material at your pace a little bit at a time to get the information. So what I want to do today is just introduce you to the basics. And I'm going to give you a little bit more information than what you need to pass the test, but I think it's good stuff that you're going to be able to use for, when you're an actual pilot out there in the field and you need information. I figured while I'm at this, I might as well show you some tricks as well. So let's get into this right now, and so that you can see what I'm talking about. First of all, let's talk about aviation weather reports. Where can you get those? Well, you can get them at aviationweather.gov, and once you put that into the address bar on your browser and you hit enter, you should get this page. Now, if you look, I'm going to draw you an arrow to the top of the page here where it says METARs. That is where you get your hourly by hourly information on weather. Now, of course, it has to be from a location where the weather is being reported. So they have these systems at different airports called AWOS and ASOS, and they report the weather that ends up on these METARs. And this, again, is an hourly service. So every hour, not necessarily on the hour, but every hour or so, they're going to update this unless there's some special conditions that cause them to need to update it because there's significant weather changes, sometime in between the hour. And we know that especially here in Florida, you're going to see weather changes that can occur much quicker than an hour, regardless of what the weather has been or what's forecast. So METARs, every hour, updated, and let's take a look. First of all, you click on this METARs button at the top of the page here, and it takes you to a page that looks like this. And if you look down in the lower 1/3 of the page here, I'm going to put an arrow. There's a request METAR data, like where do you want to get the information from? What airport do you want it? So there's special codes that we use to identify airports, and you're probably familiar if you live in the Tampa Bay area with TPA, which is Tampa International, or if you haven't, if you're not knowledgeable about the Tampa Bay area, we can go to New York. Everybody knows JFK is the airport there or the biggest airport in New York City area, and so it's JFK. Out in Los Angeles, you have LAX. Everybody knows LAX, or at least probably has heard about it somewhere. But at any rate, LAX is Los Angeles International Airport. So you'll notice if you look real close that there's not just an SPG here. We're using Albert Whitted Airport in St. Petersburg, and so the St. Petersburg Albert Whitted Airport is SPG, but there's a K in front of it, and that K just denotes that it's part of the contiguous 48 United States. Other countries and other areas have different letters in front of their three-letter identifier for the airport, but here in the United States and the northern Americas, but part of the 48 contiguous states, using a K. So KSPG is what we're putting in there, and that's going to take us to this. Now this page here has the data. It's kind of hard to figure out what is the data and what is not, so I'm going to point to it here with an arrow. This is the METAR data, and you can see there, if you look closely, it's for KSPG. Tells you which airport it is for, and it gives you the date and time information up there as well. But we're going to talk more about how to read that information here in just a moment. So let's take a look at some actual METAR data. Now, in the back of your book is where this particular set of METAR data comes from. There's an area in your book that has all the figures and drawings and pictures that they use on the actual FAA exam. So it's literally a document that you can download from the internet, but you have it right there in your ASA book. So I took this directly from one of those pages, and there is some outdated information on here. We're going to talk about that as well. But for the test purposes, you may need this information, so we're going to make sure you have what you need for the test. So let's look a little closer. The first thing up on, you see 3 out of 5 of these has the word METAR. So it's kind of telling you what it is you're looking at, and so that you know it's a METAR and not a TAF or some other thing that, some other report that they have out there. METARs and TAFs, by the way, are the only two we're going to worry about for the test. There are 3 or 4 different or 5 different types of basic weather reports that are out there, but there's only 2 that seem to be tested on for the Part 107, and that's what we're going to focus on. If you want to learn the other ones, you're more than welcome to, but once you learn METARs and TAFs, the other ones are pretty much intuitive from there because you already kind of understand the format that they use for most of these weather reports. But again, we're going to look at this METAR, where the purple line is here, you can see, is the what. What is it we're looking at? We're looking at a METAR. METAR is 1 hour data, so it's from the time that it was reported up to 1 hour in the history of that time. So it's 1 hour back from the time it's reported. That weather that was going on in that 1 hour span is what gets reported. So it's not a future report. That would be a TAF. A TAF is a terminal it's a terminal aerodrome forecast. And aerodrome is just a fancy way, or actually an old way, of saying an airport. So then you look here next, you see the purple line has shifted, and this one is for LAX. We mentioned that earlier, and this would be pulled from Los Angeles International Airport, so KLAX, that is the where. All right, and then we're going to get into when did this occur. So we're going to shift that purple line over, and you see this string of data, these numbers and this one letter, are basically the day and time when this occurred. So if you look, this is the when, and the first 2 digits, the 1, 2 here, tells you that it occurred during the 12th day of whatever month we were in. Now, since this was pulled from a book, we don't know what month this occurred, but if you're pulling the data, it's going to tell you right now, if you know at least what month it is, you're going to know what day of the month this was pulled. So these last 4 digits are the time, and in this case, it's Zulu time. So in explaining to you what Zulu time really is, you first have to understand the 24-hour clock. And the 24-hour clock runs like this. We start out at 1 o'clock in the morning as 0100 hours. And then 2 o'clock in the morning would be 0200 hours. 8 o'clock in the morning would be 0800 hours, and so on until we get to double digits. And then we have 10 hour, the 1000 hours, 1100 hours, and then 1200 hours. When we cross over into the afternoon, we are at 1 o'clock in the afternoon. That's the 13th hour. So 1200 hours and then 1300 hours. Then, of course, 2 o'clock is 1400 hours. And then this case, we're looking at 1852. The 18 would actually be 652. So the best way to get to that number is to subtract 12. Obviously, at 1300 hours, you subtract 12 from the 13, you get 1. And that would be 1 o'clock in the afternoon. At 1400 hours, we subtract 12 and we get 2. And in this case, 18 minus 12 would be 652. So that's kind of the military time, as some people call it, or the 24-hour clock. And, that's pretty simple. You probably should set a clock in your house if you're not familiar with this time. A lot of digital clocks can be set to a 24-hour time. So it's a good thing to do, to set one of your clocks at least to military time or the 24-hour clock, and the rest of your clocks can be, normal. So this way, as you're walking around throughout your day, you can reference yourself to the time and get more acclimated to it, to where before you know it, it's just going to be standard to you to be able to do this quickly in your head. So that's the first part of Zulu time. And then the second part of Zulu time is knowing where this time comes from. And there's a line that goes, it actually encircles the earth, and it's where time kind of stops and ends for the day. And so it runs through this place called Greenwich in England, and that's where they have the world clock. So everything is gauged from Greenwich, England, on over to where we're at and beyond. And so they have lines across the ocean and all the way here to where we live on the East Coast, and then it continues to dice up the United States another 3 or 4 times as we go out and around into the Pacific Ocean and back again to the beginning of the next day. But the way we derive this time is currently, because we are in daylight savings time, which runs from basically March of the year all the way through November of a year. We're right now subtracting 4 hours to get to that time. So if it's if the time is right now, let's say 4 o'clock in Zulu time, then it would be 12 o'clock here in the East Coast of the United States. So New York or Florida time would be considered minus 4 hours. So if you think about it, the sun's moving this way, so obviously the time of day is going to be more in England. So as we get into the afternoon or any time of day really, the sun is, coming across the earth as the earth's spinning toward it. The sun is coming or appearing to come across the ocean and come where we're at. But by the time it gets here, it's much later in Greenwich, England than it was at first. So it's going to be much later here time than it was there. Or actually, the time there is going to be later than it is here because the sun hasn't gotten here yet, or that part of the day hasn't gotten to us yet. So again, daylight savings time, we're subtracting 4 hours to get to that time. But when we're in standard time, which occurs from November through to March again, it's a 5-hour difference. So you have to keep that in mind. The majority of the year, it's daylight savings time, and it's a 4-hour difference. And as we go into winter, that becomes a 5-hour difference. So that's the important stuff you need to know there. Let's move on to the next piece, which begins the weather piece. And let's see, there you go. We've got the purple line now at the beginning of this weather information. And in this case, we have the wind. If you look at the first 3 digits in the wind calculation, we have the direction that the wind is coming from. And in this case, it's 250. So if you're looking on the compass, or if you're looking at a compass rose, straight up north is either 0 or 360, which in aviation we call that 360. And then all the way 90 degrees from north is 9 or 090. Down south is 180, and then 90 degrees to the west is 270. So if we're looking at a wind coming from 250, it's a little bit past the 180, and it's not quite 270, so it's in between there, so it's coming from the southwest. So this tells you which way the wind is coming from. So if it's blowing from 250, that's the direction. Southwest is where this wind is coming at us from. The second part of that equation is the 04 kT, and that is how fast the wind is going. The kT tells you it's calibrated in knots, so this is 4 knots wind. The next set of information we see is the generalized weather and sky condition information, such as your visibility, any significant weather, and where the clouds are. So let's look at the first piece of that, weather, and that would be the 6 statute miles that's represented here. So the SM stands for obviously statute miles, in this case 6 statute miles. And then we're going to move over, by the way, that's the visibility. And then we're going to move over to the next piece. This is not always, there's not always something in here. This is like significant weather, like rain or thunder showers or thunderstorms rather. You know, those types of things where there's significant weather. Snow might be in there, or hail or ice pellets and things like that are in here. And that's where the bulk of the coding comes from that that takes so long to learn, because some of it is intuitive where you can look at the code. It's kind of like an abbreviation of that weather. And then there's others like this one we're looking at for mist, believe it or not. Mist is BR. So it makes it kind of tough to learn unless you have given yourself a way to memorize it. So I myself and many other people, when they're learning this, assign their own kind of code to the codes. For me, BR now stands for baby rain, and baby rain would be mist. So you can think of it like that, and as you're going through the coding in the Bendix King manual on weather coding that I left you a link for in the links area, as you're going through that, go find the list of codes and assign it your own fun way to, you know, remember what they are. All right, so moving on, in the weather, we've got the significant weather area, and the next up is the sky condition. And in this case, we've got SCT at 2 different levels, and SCT stands for scattered. And again, there's more codes for the different cloud layers and types and all that stuff. So you'll want to make sure that you've learned all of that. And again, that's all in that Bendix King manual. You really need to study that, get to know that, take some time with it this week, and really understand that. But in this case, we've got scattered clouds, and the 007 means that we're talking about 700 feet. And the 250, or the 250, is really 25,000 feet. You're going to add a double zero to the end of every number with your sky condition. And then scattered, you know, there's like 8 different ways that the clouds could be. In this case, the sky is cut up into how much of it can you see? What's the ratio of clouds to blue sky? And then they have, no clouds conditions all the way through few and then scattered and then, all the way up to completely overcast skies. And overcast would mean there's clouds everywhere. You can't see hardly any blue. And if you do see any blue, it's just a little crack and then it's, cloudy. But scattered is more like there's a lot of clouds up there, but they're scattered. You can see blue in between them. So it's not completely covered, but it's not few. Few would be like you've got a lot of blue and a few clouds. So you've got to really learn those codes, and they break it up into what they call octas. So the sky condition is considered in eighths. So 1/8 of the sky covered would be your few. 3 to 4 sky coverage, 4/8, 3 to 4/8 would be more like scattered. And as you move on, eventually 7 and 8/8 would be your overcast. So definitely, again, read that manual. You'll gather all of that information from there. The next piece here is your temperature and dew point. The first number, in this case 16, is your temperature, 15 is your dew point, and that would explain why back here you have scattered clouds at 700 feet. Because when your temperature and dew point are within 2 to 3 numbers of each other, you can expect there to be lower clouds. There's a whole kind of a mathematical way to determine that, and we'll discuss that at some point in the lessons. But for right now, you just need to know that there's your temperature and dew point, and when those numbers are close to each other, you can pretty much expect some low clouds, maybe fog, or at least kind of poor visibility kind of days. In this case, not so bad. 6 miles, statute miles of visibility is considered really pretty good. So again, temperature and dew point. The last one you see in this rack of information is the altimeter setting, which is really the atmospheric pressure in mercury. So if you're a pilot, you're setting your altimeter to this setting of whatever the air pressure, the atmospheric pressure is for that day and time. And it would be in 4 digits like this, but there would be a decimal in the middle. So you have 2 numbers, a decimal, and 2 more numbers. In this case, it would be 29.91. Now that's pretty close to a standard day because a standard day is 29.92. So this is low pressure, but it's very minimal low pressure. It's not far off from 29.92, but nonetheless it would be on the low side. You might see numbers like 29.87 or 28 or 29.90. The less the number, the lower the pressure, and of course the higher the number, the higher the pressure. You could even see 29.98 or 29.99. So that would be very high pressure. So again, these are altimeter settings, and it is your pressure settings. Now let's take a look at some things that aren't typical on your current day METARs, and also let's look at some things that are in there that aren't part of this normal piece of information. So first of all, I want to talk about up here, I'm looking at K, I, and K. And like I said before, most of us know the big ones like TPA being Tampa and MIA being Miami, JFK being New York, LAX being Los Angeles. But I don't know this one with I and K. Now, they're not going to allow you to do what I'm about to show you on the test. So what I'm really showing you is something that you could use for later if you ever needed it. But where would you find the information if you had an airport that you're not familiar with the IACO code for that airport? Well, you go to skyvector.com. It's one of the quickest ways, I think, to find this information. It's the one way I'm going to show you because it really is easy to use. So let's take a look at that. Use skyvector.com in your address bar and hit enter on your browser, and you are taken to this page. If you notice up here in the left-hand corner, it has the KINK in it. That's because I put it in there. After I brought this page up, I went into that left corner box and put the new airport identifier in there that I want to know more about. Once I do that, there's a little go button there, and as soon as you hit the go button, it takes you to the area where that airport is, and it will identify it for you. From there, if you look here in the left-hand corner, it tells you the name of the county in this next page, and it gives you a little blue dot with a small letter I in it, and that's for further information. If you click on that small I, it takes you to a page that looks like this, where they're going to give you the coordinates of that exact airport. They're going to tell you in clear English terms where that airport is located, so when you're looking on a map, you can find it easier, and it gives you the elevation there. Then if you want more of the operational data or information for the airport, it's located here. Airport communications, so all the frequencies for the tower and the weather and the Unicom and all the stuff that we're going to talk more about in future lessons, it's located here. And when I teach that stuff in future lessons, I'll refer back to this so you can remember. So lots of information here, the dimensions of the airport and the runways and all that good stuff. There's a wealth of information located here. So now let's take a look at some other kind of different things that you might see on this METAR information. First of all, I'm highlighting 15 statute miles in this top one at KINK. And I highlighted it because we don't normally see numbers above 10 statute miles anymore, because the reporting equipment really, for most airports, and it may be all of them nowadays, only report out 10 miles. Anything above that, anything when you hit 10 statute miles, it's considered infinite visibility anyway, because it's really good visibility. Okay, so the next one I wanted to show you is they've even got on this next line 30 statute miles of visibility. Just unheard of in today's situation, but if you've got 10, anywhere around 10, even 6 is good. 10 is exquisite, so they just don't go beyond that much anymore. All right, so I've now highlighted in the lower left-hand side, you see where it says SPECI, S-P-E-C-I. And that's a special weather report. It's still a METAR, but it comes out when there's a significant change in the weather. In this case, what brought this on, if you look at the far side, I've underlined it in green, it's a remark. RMK stands for remark. And it says that the rain began, or R-A-B, so the rain is R-A, rain, and then the B began at 35 minutes after the hour. So it gives you kind of an idea when this report came out. Of course, you can see when it came out over in the day and time, but it's saying that, the reason for this was it was rain. Now I'm highlighting a non-standard distance number for your visibility. In this case, 1 1/2 statute miles. When they want to put a half or something like that in here, you're going to see a number with a space, and then your number, or like your half or your fraction or whatever you want to call it, the fraction bar is a slash. So you have 1 1/2 statute miles visibility on this portion. Next piece I'm showing you down here, and the next specie for JFK, I've underlined it in yellow. If you notice to the left, it's saying FG, and that is fog. And they're saying the runway visual distance for runway 4 is 2,200 feet. So the runway visual, 04 gives you the runway, and then, so the R is the runway visual, and then the 04 tells you the actual runway, and then it tells you you're not seeing past 2,200 feet, which, if you know that a statute mile is 5,280 feet, then you can tell this is well under a half-mile visibility, and it's probably due to the fog. So moving forward, let's take a look at a TAF. Now, TAFs have similar information to what you see in a METAR, but there's a few differences. First of all, a TAF is for the next 24 hours. It's a forecast, terminal aerodrome forecast. That's that F. So that F says forecast. It's giving you 24 hours out what they're expecting. Now, it's updated every 6 hours, and that's important to know that it's updated every 6 hours. So these change a little bit because forecasts are never perfect, especially not here in Florida, as the weather changes constantly. So you want to stay up on these. You know by the time when these come out that within the next 6 hours you're going to get some kind of an update. So let's take a look. Now the first says it came out on the 12th day at 1720 Zulu, and its period of validity, or when it becomes valid, is actually on the 12th day at 1818 Zulu. The next piece here, you see PROB, which means probability, and then they give you a percentage, in this case 40% chance. So there's a probability 40% that the information you're going to see from this point further is going to be what the forecast holds. The next one down here, you see FM stands for from. So they're saying from 2200 hours, this next string of data or information is going to be what holds true. So you see here they've got winds coming from 330 at 15. And while I'm here, I might as well explain to you that the G in the middle of that stands for gusting, and then they show you 20 knots. So again, right there, I put it with a yellow line. You can see 330 is where the wind is blowing from. So really kind of the northwest is where the wind's coming from. And it's standardly 15 knots, gusting to 20. Now here you see in the visibility section that it's not only just 6 statute miles, but there's a P with it. Just remember the P means plus. So it's greater than 6 statute miles of visibility in this case. Now you see under with the blue line under it on the third line down, the BECMG, which stands for becoming. So they're going to say that the weather will change to becoming what they're stating in the next line at a specific time. If you see tempo, that means temporary. So temporarily the weather will change to the next piece at a specific time. And then when you see the equal sign, that means you've run to the end of the TAF for that particular forecast. So that, in a nutshell, is what your METARs and your TAF is about. And that will end the lesson for today on this. So again, I'm showing you all of this up front because it's important if you want to get a really good grade on the test. And it's going to take the longest amount of time for you to get acclimated to all these codes. I don't know if I were you, if I would worry too much about the codes for snow, or any of that kind of stuff necessarily. The questions on the test are pretty normal stuff like mist, which we showed you, and rain being RA, thunderstorms and showers, SRA, or rain and thunder showers and that kind of stuff. SHRA rather, not SRA, SHRA. So get to know those types of things, the stuff you would normally see on a given flight. That's really the big stuff. They're not going to put tornadoes or dust blowing and that kind of stuff necessarily on the test. But the more you know, the better off you're going to be. So spend some time with that Bendix King manual, and let's look forward to the next lesson. Have a great day.